என்ன இருக்கு?
Okay, so just we just I am going to discussing and sharing my view on why how we are going to convert this normal analog sensor. Is it audible?
Yes.
Yeah. Why we need to convert any sensor to IoT sensor, and how we are going to do that. So for that two questions, I am going to probably I thought of answering to that. Right. First, why we need to convert any analog sensor into IoT sensor? Right. So do we know in the normal analog sensors when it was calibrated at last? Last time when it was calibrated? No. So the analog sensor, for example, this flow meter, this will give only pulse. That is the only information you can get it externally, unless if you are making some notes, right? And when it was installed in the site, so do we have this information remotely? No, you can't able to get it. So what is the model number of the device which is installed into the particular area? That you won't get in the existing analog sensors. And what is the serial number of this device to check whether this if we have a defect, and what is the serial number that we have to go and read it manually, and what is the lot number it was supplied for further analysis. So if this is a lot failure, or this the failure is restricted to this device, for to know this, it is not possible in the existing sensors which is having the mechanical sensors which is currently available. And what is the internal temperature of the sensor? We can't get it. And when it was, if it is in a power device, when it was the last power cycle, when it was restarted, how long this has been running? If it is in a battery based device, so how much battery power will be there for and how much battery power has been consumed, and how much battery power will be there for the future running, right? How to calculate the actual value, right? For example, in this flow meter, you will get the only pulse count. As an end user, you should know how much liter has been flowed, right? This kind of analysis now the people are doing in the SCADA. So if you just assume that if this information we get it from the flow meter, then this will be useful for everybody. The people can in the site can read the value actually, right? They don't want to depend on the SCADA in this case. And who has installed the sensor and where it was installed? Is there any possibility of getting this data? No, with the analog sensors. So that is what we recommending to convert all the analog sensors into the IoT sensor, right? So converting those IoT sensor is much costlier, you think? If right technology people is there, then it is very cheaper actually. So considering this flow meter, which I shown earlier in this image, this cost would around 1 lakh to 1.5 lakhs, right? So if you in the second right of this image, if you see this Raspberry Pi board, you might have come across. This board cost around 3,000 to 4,000 rupees, right? If for the demo I'm showing this, if this will be in the regular manufacturing, this would cost maybe you can take it more than 4,000 to 5,000, and we can add some more values of like 5,000 for the software. By adding this 10,000 rupees, we are going to get those detail in this existing flow meter. see how much of benefit we are getting to converting the analog to the IoT sensor, right? So any IoT sensors, there are three important characteristics. It should be intelligence, right? So how the intelligence will be added? It should have some kind of processor that do the processing, and that should hold the values of these parameters, right? These parameters that should has, then the intelligence automatically it will come, and this have a unique addressing. Since in the 4.0 architecture I told you that any SAP devices or any analytic devices that they can go and fetch the data directly into the device field device. In that case they need unique addressing, right? Some unique address it's mandatory on this IoT sensor, and this has to send the data while change, that is report on exception. These are the main three key IoT sensor characteristics, and for sure this will be the future, and this will going to happen in across the all industries, not only in renewable sector or manufacturing sector or medical sector. This will be the future. The devices will be going to convert. So see the potential of the need of engineers, the real engineers, those who can able to convert this analog sensor to the IoT. So how much potential we need in India, right? What we have now is in a 5% or 10%. So we need to convert those devices into IoT. Then see the potential is required to work on this product development. So that is what the future what we are expecting. And this is the future trend. Just I want to explain you that the non-IoT devices and IoT devices from 2015 to, and the projections till 2025. Right? In 2015, you see 3.5 billion devices, 3.8 billion devices of IoT device, which was there in 2015. First, you take these non-IoT devices. You see the difference is in 2015 it is 10.1 billion, and in 2025 it is 12.7 billion. So across 10 years, there is more than just only 1% of device, 1%, not 1%, 1 billion devices alone it increased in the non-IoT. So it is almost saturated. So market has been non-IoT market has been expecting to saturate in it, but I won't say it will be null, but it will be saturated, right? But if you ask me that 100% IoT enabled, then definitely that will be null. But if you see the red color, right? So it started 2015 with 3.8 billions, and now it is 9.9 billion IoT devices, and it is expected to grow in 2 times, sorry, 1.5 times in 2025 within 5 years. Even my expectation that will go more since the evolution of this analytics. The people started doing analytics and they understood the need of the data. But for doing the analytics, the clean data is one of the major requirement. To give the clean data, the IoT is the best way to achieve this clean data. Right? So I want to share you some real-time use cases, how the MQTT has been working in renewable sector. In this case, inverter or it may be the turbine. So all the devices I assume these all the devices are IoT enabled, right? So it can have a capability of sharing the data, and whenever there is a change, right, it share the data to the MQTT broker which is available in the same plant, and this MQTT can share the data, subscribe data to the SCADA, and in parallel this MQTT broker itself talk to the another broker to share the plant related information. So this will be the central location. This part will be the central location, but similar to this, we might have several other plants also. Right? From all the plants, the MQTT broker, this broker this MQTT broker will act as a broker as well as client. For the partially this will act as a broker and partially this will be the client to the another broker. So why we introduce the broker here? In case of any communication failure between the brokers, it has a queue. That is the functionality of the MQTT message queue. It stores the data in the queue. Whenever the communication restores, the protocol itself take care of pushing those data to the MQTT, right? So from the MQTT, the unified namespace will be fetching the data, and whomsoever need the data in the MQTT broker, they can fetch through the unified namespace server. And the same device can be used by machine learning team, and same this broker can be used by the data analytics team, and this is how the future network will be. So this is the pilot, maybe the future network for any kind of industry, right? I thought of sharing just a small demo how the MQTT is working. So I am going to run. Okay. So if anybody want to participate in the demo, so they can also do this exercise. Probably you can go to the your Play Store app and you can download the MQTT client. And once you download, you can open the client. Um, you can see there is a tab. This is the place we need to enter the host ID. So broker.hivemq.com. So that you need to configure and you need to keep the port number 18183, right? So and select the quality of services too. This is the prominent good service. And once you click a connect, once it connected, then you can this is the two tabs. This is the for topic for subscribe, and this is topic for publish, right? Once you made the topic, right, you can able to send the value. So if you send the value, if you want to publish, if you publish the data, you can see that data will be available in the broker. I can run the broker now. So just a moment. And I want to show my mobile also. I will open my mobile in the T2 160. So anybody wants to, I think you can unmute and tell me that anybody interested to install this in your mobile phone, or anybody is doing that.
Yes, we are trying, Murugesh. Could you
Yeah, yeah. So if you want these screens.
keep it like that. Once that will connect it.
Okay. So you just
What is
this,
it, bro? Topic to subscribe. Test.
yeah.
Okay.
Just a moment.
Please hold the screen as it is so that we can do it.
Okay, you can. Sorry. test pub. You can use this topic. Test, TESTPUP.
Okay. Thank you. We are entering. 1 second.
Just copy paste. It will
Then we can connect it, right? That's all. Okay.
Yeah.
clear. So you can copy paste.
So sorry, sir. I'll do that.
That will be easy.
That.
Chat message also you can send.
Yeah, this is the broker you need to connect. So this web socket don't do that. So you only use the TCP port 1800. So in this case, here in your mobile phone, you have this host location, right? Here you just type broker.ivmq.com.
Could you just, can you show the screen?
Sorry.
Yeah, hold on.
Yeah, whenever mobile goes in sleep, then it went to black.
Okay, thanks. Okay, send. Then we have to do the send or what?
No, you just subscribe the test pub,
Yeah, that is already done.
right? If I'm right now I'm typing some other value, right? 76.
Once,
Will you get it this message?
No, not.
Yeah. Whether it is connected here?
Yeah, I got that value 76.
You got the value, right?
Yeah, now we got it. Yeah. Now
Yeah,
we got it.
you can and you can also publish. For example, Vinay, you can publish some value by typing here.
Yeah, I'm doing it. 1 second. Hold on. 115 we have done.
Yeah, it is received here.
Okay, thanks. Super.
So this much fast this MQTT is irrespective of any number of connections. Right now we are testing 3
So
people.
this way we can send any numerical and alphabets, right?
Yeah, anything will send. But this app may be limited to some kind of development. This is like a test app.
Okay, clear.
Okay.
Thanks.
But in real time, even what I understood from my friends, they have handled the millions of connections.
Okay, super.
Without any delay, it can post all the data into the network.
Okay.
Right?
Yeah.
Hope anybody wants to do or we can proceed. Right? We'll proceed. So I think in my presentation part, that's it. Maybe the next one is question and answer. So probably I just waiting for your queries. So let me see that what are all the things which already received the chat.
Can you ask the questions?
Yeah.
The point is, are you conducting any kind of training for this?
No. This is my own interest.
Okay. If anybody wants to know about IoT, where they can learn? There is any institute or any who can teach something like that?
I'm also seeing that there are some even some IIT also they announced the course, but I don't know exactly what are all the things they are just giving us a training. There are some courses available even in Udemy and some other online courses, but I'm not sure. I didn't go through it. But this I have got an interest sometime back. Before 2 years I started working on this MQTT. Then I dropped for some other reasons, for other commitments.
Okay.
Even I did MQTT broker in Raspberry Pi 2 years back.
Okay.
Our internal testing that went well actually. So yeah, you can see a lot of videos in online. but you need to go through some kind of standard specification. If you are really interested on IIoT, developing a device in IIoT, nowadays there are some standards available. That is Spark Plug B. That is
Okay.
one of the major standard which has been used. Everything is online. It is available online, and moreover, this Spark Plug B has been maintained by the Eclipse Foundation. It is
Okay.
open source. So you can maybe the 76 page manual, the how the protocol has to be used in the client devices. If you are going to develop a client, MQTT client, in that case you can go through that specification and try to adapt those specification that will help you in the integration of the MQTT in the common stream.
Okay. Clear.
One more addition to it. MSME also conducting some programs regarding this. You can check their website.
Okay. Thank you. Thank you. I'll do that.
So any other questions? I am unable to see the chat box. I'm trying to-
One question from Varun, I think.
Yeah, Varun, can you unmute and ask?
The question is,
Yeah.
is
Yeah,
there
yeah.
any
Actually,
security
that
concern?
sense.
One second. The question was, it is like, is there any?
Yeah. Is there any security concern over the network? Yeah, definitely. That is the only weakest point so far initial days, and now the 2.1 is security enabled. That is TLS and the SSL is enabled network available in the IoT platform. Yeah, there is obviously there is a security concern definitely will come. Why? Because in earlier 3.2 architecture that will be like Poland the Poland response, which is limited to the space. But now we are opening the network across the plant. In that case, security needs to be taken, but now the standards are available. Security standards are available. So only thing people need to adopt those technology. So because obviously this is a good technology, we need to security will be improved in over period of time once we started using. But nowadays we have a security that SSL is there. SSL and TLS is enabled.
Can you go back to this IoT architecture slide?
4.2 architecture slide, Balaji.
4.0.
Yeah, that's all. This one.
Yes, this one.
Yeah.
In this, there is communication layer 2 and layer 4. You have access to broker, but this analytic layer can directly access from layer 2 to layer 4. No,
Yeah, layer 4 is the analytical layer.
but the main source of data lies in layer 2. But why do you have to get the data from broker?
No, that's why the telling in the current 3.0 architecture now we are getting only data from the SCADA, right? But in future thing we may reach the PLC directly and we may get the data. If in the SCADA we won't say that we will take all the data, right? So if you to do the analytics, what you need is you need to get all the device data into the SCADA server. From the SCADA server you are fetching now. So the future trend will be like, so this layer will get the data through the unified namespace. Whenever new device added, you don't do anything. So only if you enroll this device in the unified namespace, this analytics layer or any devices, they can fetch those devices through this unified namespace. Once you put this, subscribe this unified namespace, whenever there is a change, that will push the data to the broker, and even that provision has been made in the analytics area also.
Okay,
So
then it means
you don't
that
depend on the SCADA server alone for the data. You can directly fetch the data. Yeah.
So there will be two layers of data storage, that is in SCADA as well as in analytic layer. layer 2 and layer 4. Is it correct?
No, I'm not getting. So data storage will be in the layer 4. Yeah, some data will have a layer 4. You don't need to store the data. You can fetch the data from the PLC itself. Okay.
If that is the
Analytics.
case, then there is a question come across. PLC has its own limitations of data storage, right?
Yeah. So I'm telling about the real time data. You maybe Balaji, you are telling about the stored data.
Historical data.
Yes.
Okay.
You have historical data at layer 2 as well as
Historical data.
some
Historical data will be maintained by the analytics team. Yeah, each and every layer, every device, SCADA as well as analytics, they maintain their own data. Even now we are not taking the data from the SCADA, right? You are taking from the another device. SCADA will collect the data and push the data to the server, another central server. That central server memory only you are using for analytics. Similar way, that central server memory storage will be there. That will store the data. But to storing those data into the central server, this analytics layer will tell that central server to store which data instead of storing all the data. Balaji, is it fine or?
okay, sir.
No. Even now in the current situation, you are not getting you are not accessing the stored data in the SCADA server. Right? Periodically, what we are doing, we are pushing the data from the SCADA server to the central location. There will be central server is there. That server anyway will be there. To storing that data, we are not going to store all the data. Whenever there is a report on exception, that data will be stored. But before storing that decision is made by the analytics server. What data alone they need to store. That is an application layer development.
Okay, sir.
Okay. So okay, sir. NL, are they using this technology, sir?
Sorry?
Okay. Manimaran Krishnan is telling that yes, NL Italy is already using this technology. Wow, that's great. They are advanced. Right. So any other questions?
I think people, if they don't have the questions, and then we can.
Yeah. We can wind up.
Yeah, we can wind up. Thanks for nice training program.
Yeah, thanks, Vinay. And
Is it possible to get your mobile number so that I can talk to offline?
yes, I have that. Just a moment. Sorry, that slide I didn't show.
Yeah.
Oh, sorry, Mr. Yeah, sorry to all. This is Shanmugam. Mr. Kudia, sir. Mr.
Yeah.
Kudia, sir. Yeah. Actually, I have a small question about the when we talking about the data transmission. Uh, the light you are. Yeah, I seen this something like the data traffic will be lightweighted. So the data will be lightweighted. So normally in TCP we for example for the flow meter or for the power consumption sometimes we use 2 bytes normally, sometimes we use a 4 byte data. So so the whether this data will be using for Modbus or maybe some other substation related protocols or some other. So it's over the TCP. So if the big size of data, for example, the big size of data, the power consumption will be sometimes the 4 byte also not enough. Maybe it needed for more big size of data, big size of range of the value. So what I asking that how this protocol will manage this the with the lightweight of technology, that how the data will be uh, transmission between the client and servers.
Yeah. So good question, Sundar. Actually, the thing is, the lightweight. I'm telling that in HTTP, if you go on HTTP, for this, it has some complex headers. If you go through the Wireshark, you can find the headers other than data. Right? You will find the data at the end of the header only. Right? Payload will be the last.
Payload.
Right, before that you will find some headers close to 128 bytes. So it has the port number, source port number, destination port number, source address, destination address, and what is the sequence number of earlier transactions. Right, that
Yes.
information if you see in the TCP, that is HTTP based. Right, so that gives the flexibility of to avoid the failures. So the retry, if something goes to retry, then you can find those detail in that. But in MQTT, there is only 2 bytes, but it has been handled by the quality of service. So because of that, people are telling it is lightweight, because even they compromise some of the security, not security, some features, but for this application, that is not required. So that's why they introduced the QoS method, quality of service method. Whether you need to, you don't worry about that fire and forget. Right? The Q, if your QoS 0 is selected, there isn't a fire and forget. You just throw the message. You don't worry about whether the broker has received or not. In that kind of application, for example, in the transport, so transport tracking, right? Some of the transport companies there, if they want to track their truck. So whenever they have a network, they will try to push the data and they will send it away. They don't wait. In that case, they use the quality of service 0. But in quality of service 2 is somewhat similar to what we have a sophisticated environment. That's how the even the major companies like YouTube, Facebook, and everybody using this as a reliable network. So it again the compromising the size a little bit compromising the size, but it is better than what we have in HTTP. But HTTP has their own advantage. In co-op, you can use co-op, we can get the HTTP feature, but that little header will be added. So in the same header, you will get it in the HTTP also. But in the MQTT, if you go
Yeah.
through the Wireshark, you will see only 2 bytes. Even 1 bytes for if it is the payload is more than 127 bytes, less than 127 bytes, this is 1 byte. If it and the payload goes more than 127, then it will be the 2 bytes. So
Okay.
you can do that experiment in by using this Wireshark. So you will know that what exactly the difference.
Yeah. Thanks. I will do it in I will do it
Yeah.
internally. Yeah.
Yeah.
If anything, I will let you know.
You can check it and reach me. No problem.
Yeah. Yes. Thank you for thanks for your detailed information for during this meeting.
Yeah. So, sir, so that we can, shall we wind up, sir? I think people don't have any questions. Right, team, thanks for joining in the call. So, if any questions, please write me or send a email to me so that I'll try to find out and I'll explain you better.
Thank you. Thank you, Guri.
Yeah, thank you.
Thanks, sir. Sir, Magendran, sir. Hello, sir.
கேட்குது, எனக்கு கேட்குது.